Welcome to Calculus 1 class. Today we're going to review what we so-called the combination of functions. If I have two functions, I can combine them by adding, subtracting, multiplying, and dividing them. Okay, so this is called the composition of functions. Excuse me, they call it combination of functions, not composition. So if I got two functions, I can always add, subtract, multiply, and divide them. So let's take a look at some example how we gonna add them, how we're gonna do the operation on the two functions. Alright, so for example, if I have a linear function 2x plus 1, another linear function x plus 1, let us see how we're gonna add them up. It's actually pretty easy. If I want to add two functions, okay, we take the first function 2x plus 1 and add on to my second function g of x, and all I gotta do here is just combine like terms. 2x plus x is 3x, and 1 plus 1 is positive 2. Now since my answer is also a linear function, then the domain for a linear function, which is a straight line, will always gonna be from negative infinity to infinity. So parenthesis, negative infinity to infinity. Alright. Subtracting functions is a little bit trickier. If I take the first function f of x, subtract g of x, my first function 2x plus 1, minus my second function x plus 1. Now since my second function is two terms representing one function, I will need to put them in the parenthesis so that this negative 1 will do a distribution on those two terms. Otherwise the answer will be slightly off. So 2x plus 1 will stay the same. Negative 1 times x, negative x, negative 1 times positive 1, negative 1. So when I combine like terms, that will just give me x, which is again linear function. So my domain, negative infinity to infinity. Alright, multiply two functions, the product of two functions, f of g. So again, my first function f is two terms represent one function. So when we multiply them, I will need to put it in the parenthesis. So that's function f times function g, x plus 1. Two terms representing one function, put them in the parenthesis. Alright, so here I'm looking at 3 terms times 2 terms. So I think about FOIL methods. 2x times x, 2x times positive 1. That will give me 2x squared. And a positive 2x. Inner and last, 1 times x, 1 times positive 1. That will give me positive x and a positive 1. Combine like terms, I should get 2x squared plus 3x plus 1. So this answer is a quadratic function. I'm just say QUAD. Alright, a quadratic function produce a parabola, a vertical parabola. And vertical parabola domain, one side keep on going to the right, the left side keep on going left. So my domain will be the same, from negative infinity to infinity for a vertical parabola. Alright, division is a little bit trickier. The quotient of two functions. If I take my function f of x, which is 2x plus 1, divided by x plus 1. Okay, when I write it out this way, it creates a rational function. So the first thing I got to think about is can I factor my numerator and denominator, where the top and bottom will cancel out. And whatever I cancel out will be the whole in my function. And whatever I do not cancel out with the denominator, that will become the vertical asymptote. So by looking at these, the top and bottom, there's nothing can be factored out other than 1. So that means nothing can be reduced. Alright, so for my rational function, I know in my denominator, okay, that x cannot be -1. It will, if it is, it will be my whole rational function will be undefined. Alright, and at the same time, this x equal to -1 will be my vertical asymptote as well. Alright, so let's graph it. For rational function, I would like to graph it and just to look at the picture so I can determine what my domain will be. The numerator is 2 terms, put it in the parenthesis, 2x plus 1. Close parenthesis, divided by, denominator is 2 terms, put it in the parenthesis, x plus 1. Alright, so ahead of time I kind of already know my x cannot equal to -1, and I have a vertical asymptote at -1. So here we go. Alright, so here I have a vertical asymptote at -1. I'm gonna make that into a red, a little bit thinner, make it red. Alright, so my function does not exist at -1. So if I look at this graph, once I keep on going left, once I keep on going to the right, so my domain got to be from -infinity, from small to large, approaching to this x equal to -1, and then pick up from the other end, from -1, going to the right. So my domain got to be from -infinity all the way to -1. Use a parenthesis because I cannot be -1. Union on the other side, from -1, keep on going to infinity. Alright. Let's try another example. Same thing, add, subtract, multiply, and divide them. And this time I'm going to combine a linear function with a quadratic function. So let's do the adding one. Alright, a plus g. That's gonna give me, so that would simply be 2x minus 1 plus my quadratic function. Combine like terms, x squared still x squared. 2x plus x, positive 3x, and -1 minus 2, -3. So after I add them up, my answer is still a quadratic function because the x squared. So that tells me for my vertical parabola, my domain will be from -infinity to infinity. Alright, subtracting. And we always need to watch out when we subtract two functions. Have to be a little bit careful with the second function. The first one, 2x minus 1. Now we'll need to subtract the second function, which consists of 3 terms for one function. So if I got 3 terms representing one function, I need to put them in the parentheses so that this -1 times will distribute to all 3 terms, so our signs can be correct. Alright, 2x minus 1 stayed the same. -1 times x squared, -x squared, -x, and -1 times -2, positive 2. Alright, so combine like term, negative x squared. 2x minus x, positive 1x. Negative 1 plus 2, positive 1. So this is going to be, based on the transformation, this parabola will actually open downward. Still a quadratic function at the end. So because since it is a negative 1 up front of the x squared term, we know this parabola will go open downward. However, though, the left side is keep on going down and left, the right side is keep on going right and down. So as far as domain concerned, it will still be from negative infinity to infinity. Alright, multiplication. F times G. Let me just say FG like that. Alright, so 2x minus 1, put it in a parenthesis, 2 terms for one function, times another function, consists of 3 terms. So this is just a good old distribution here now, when I multiply them. So we say 2x times x squared, 2x to the third, 2x times positive x, positive 2x squared, 2x times negative 2, negative 4x. Alright. Negative 1, start doing distribution. Negative 1 times x squared, negative x squared. Negative 1 times positive x, negative x. Negative 1 times negative 2, positive 2. Combine like terms. 2x to the third, got no one to combine with. 2x squared minus x squared, positive 1x squared. And negative 4 minus 1, negative 5x, and a positive 2. Alright, so if we graph this function, I believe this is a cubic function, so it will look something like this. Alright, where one side keep on going left and down, the other side keep on going right and up. So my domain will be from negative infinity to infinity again. Now division, let's see. If I write this thing out for the dividing of the two functions, 2x minus 1 over x squared plus 2 plus x minus 2. Alright, so this is going to be a rational function. I don't think, even if I could factor out the trinomial denominator, I don't think the top and the bottom will ever be able to cancel. Alright, so let's see what the x cannot be in the denominator. X squared plus x minus 2 cannot equal to 0. So at the same time, I'm also going to end up finding my vertical asymptote. This is going to be x and x. 2, I can use 1 and 2. To end up with a positive in the middle, I got to have a positive 2 on the outer, negative 1 in the inner. So that means one of my x cannot equal to positive 1. The other x cannot equal to negative 2. So as you can see, x minus 1, x plus 2 cannot be reduced with the top. If I could reduce it, whatever I end up reducing will be a hole in my graph. And since I cannot reduce anything, these two factors, or these two answers here, is actually my vertical asymptote. Alright, so there's really nothing here to simplify. So this is actually my rational function in the simplest form already. So we did this part on the right just to find domain and range. So let me just graph it real quick to confirm it. parenthesis 2x minus 1, close it, then divide it by, open another parenthesis, these three terms down here. I got two vertical asymptotes. My graph will divide into three parts. There you go. So from the calculator, we don't see the vertical asymptote. That's why we kind of go ahead and find them ahead of time. So one is right here. The other one is about right here. Sorry, my line is not very straight. You just can't touch the graph. Alright, so by looking at it, this function does exist from negative infinity approaching to this -2, and my function existed between -2 to the +1, and then pick it up from the other side, the +1, and keep on going to the right. So my domain coming from negative infinity, approaching my vertical asymptote, -2, union. My function also exists between -2 to +1. And then my third part, from the right side of the vertical asymptote, x equal to 1, keep on going to infinity. There you go. Alright, that will be my domain for this rational function. And that's how we add, subtract, multiply, and divide two functions together. Alright, that will conclude this video.